to do experiment 13.2, which is on page 397. This is a calorimetry experiment, so we're actually creating our own calorimeter. All right, so what we need for this is your mass scale, a thermometer, which I have right here. Sorry. Then we need a beaker, a 250 milliliter beaker. Got 200, that's fine. An alcohol burner, got that set up right there. 2 styrofoam cups. Metal objects, which is a washer. In this case, it's a bolt. Piece of cardboard, which we're supposed to cut, and I've already cut it in advance. Kitchen tongs, scissors, which I already used, and then safety goggles. Okay, so instructions say, first of all, add approximately 100 milliliters of water to a 250 milliliter beaker. So I'm going to use the beaker here. I'm actually going to use this instead because it's easy to do the graduated cylinder. So I'm just going to take this and add our fill up 100 milligrams of water, milliliters rather. So, all right, so we've got 100 milliliters of water. It says then nest the 2 styrofoam cups together, which they are. Put the 2 nested cups on the mass scale and turn it on. If it doesn't read 0, hit it, the tare button. And we're going to pour the water from the beaker into the top cup, making sure not to spill any. Read and record the mass of the water. So there is the water going into the styrofoam cups. Then we have to figure out how much it's going to weigh, which will be, let's see. Alright, so it's going to be 100 and more. Let's see, this measurement here. Looks like 103.8. Okay, so 103.8. You want to write down for your measurement of the styrofoam cups plus water. Okay, 103.8. All right, so that's step number 5. Okay, add approximately 100 milliliters of water to the beaker again, and then we're going to put that on and heat it. So I'm actually going to start with as hot of water as I can, just to make the process go faster. So I'm going to add 100 milliliters of water. I'm going to put it here, so measure into here. Okay, 100 milliliters of water to the beaker. And then we'll light that and try and get that to heat up. See how it works here. Okay, so try and get that heating. Alright, so put the beaker on the alcohol burner stand, light the burner so it begins heating the water. Obviously don't burn myself. Alright, so forgot to remove the cups from the scale there. Then hit the tare button and get it back to 0. So move it back to 0. And we're going to now measure the metal object on the scale, record its mass. So that, let's see, is going to be 14. Let's see. So it's just about 14.4 grams. So 14.4 grams is the weight of the bolt. That's what you need for, that's the mass as in number 9, step number 9. So then we're going to put the metal object in the beaker so it warms up with the water. So this is going to be rather dropping it and damaging it. So all the way below the water, a touch above. Put it underneath there. Okay. So we're going to get that heating along with the water. Alright, so it says put the metal on, yeah, so let's see here. It's warming up there. Then we're supposed to use the scissors and cut out our cardboard circle, which I did already do. It should be larger than the styrofoam cup, so it's going to be able to sit on top, which you can see just like that. There, okay. Alright, then we're going to use scissors, poke a hole in the top, which I already did, so it fits the thermometer. And then we're going to be able to put the thermometer right in the top like that, and it's going to measure the temperature of the water. It should not touch the bottom, I think it says. So it says, put the lid back on the top, adjust the thermometer until the bulb touches the bottom of the cup, then lift the thermometer a little so the bulb is deep in the cup but not touching the bottom. You now have a calorimeter, which will look something like the picture on the left, and it just has a different type of thermometer. The screw in the picture should be in the beaker, not in your calorimeter, or not sitting next to your calorimeter. Number 15, once the water in the beaker is boiling vigorously, read the temperature on your calorimeter's thermometer. So we're letting this adjust right now while that's coming to a boil here. It says remember you can only read the thermometer to 0.1 degrees centimeters since the scale is marked off in increments of 1 degree Celsius. Record your reading. So that's the initial temperature we're looking at. So we're still waiting for that to come to a boil. Right now, it's a lot harder because our electronic scale broke. Our electronic thermometer broke, so I can use this one instead. But it looks like it's at 180. Wow, it's going to be really hard. 82.5, I'd say. Oh, it's supposed to be 1.1%. Yeah, we're not going to get that close, guys. Sorry, because I cannot get my thermometer to work. It broke, unfortunately. All right, so we're at 82.5. We're going to say right now. All right, so that's our temperature of our initial starting temperature here. Now we're just waiting for this to come to a boil, which hopefully we'll do. Actually, we'll take a break on this while we wait for that to come to a boil. So we'll be back in a moment. Go ahead, pause. Okay, we're back on again. The temperature of the cup, just so you know, went down a little bit. It's closer to 82 degrees. Now note that's Fahrenheit, not Celsius. So you're going to have to convert in your calculation section from Fahrenheit to Celsius. So it's at 82 degrees Fahrenheit.
If it were at 82 degrees Celsius, we'd have a serious problem.
We would have a serious problem, yes. Okay, so what we're going to do now is we've got to take the bolt out of the boiling water and put it in the calorimeter. We're going to read a couple of instructions ahead so you know what's going on. It says, tells us to record the temperature on our calorimeter, which we've done. Then use the kitchen tongs to pull the screw out of the water. Pull the lid off your calorimeter and drop the screw into it. Replace the lid quickly. Read the temperature, but don't record it yet. Hold the lid in place and move the thermometer around a bit to gently stir the water. If you hear the thermometer hitting the metal object, just lift it up a bit. Don't lift it out of the water. So we're going to keep reading the temperature. Then once the temperature is steady or starts to fall, record the highest temperature you read. That is the final temperature. And then we now have everything we need to determine the specific heat capacity of the object we use, which in this case is the bolt here. So here we go. So 82 degrees. Take this out. There we go. And drop it in quickly and put this in. Okay, so put the lid on. Try to keep that as much as possible. Try to move this around. Okay, so the temperature right now is at, I'm put my glasses off here, 84.5. Yep, 84.5 still. I really just see the thermometer we're working. Now let's drop down to 84 point, just about 84 now. So I think 84.5 is going to be about the highest temperature we got. Moving that around.
I think we gotta turn off that flame now.
Oh yeah, you can blow that out. You can blow it out. 80. Still right at 84 now. So I think the temperature's definitely starting to go down. Got to the highest with 84.5, it looks like. Let's see here. Yeah, it's holding this back to 84.5 again. That's weird. I don't know why it went up again. We're trying. Let's see here. Trying to keep this going around. Sorry, this is taking so long. We want to make sure we get this right. It's about 84.2 again. Now again, please note this is all in Fahrenheit, so we have to make sure we adjust to Celsius for your experimental data. Yeah, that's about 80. What we should talk about 84 point. It's about 84. Yeah, a little above 84.5, maybe like 84.6. Seems like that's it. Hopefully it'll start going down soon, then we can be done with this. Now we're down to a steady 84. So I think we probably put 84.6 is the highest temperature we got. I'm going to say that. So,
84.6?
yeah, that's all we have to record is the highest temperature we read. That is the final temperature. You now have everything you need to determine the specific heat capacity of the object you used. We'll ignore the calorimeter, so Q of the calorimeter equals 0. So we're not worrying about anything else with that. Okay, you have the mass of the water, and you know the specific heat capacity of water, which is 4.184 joules per grams times degrees Celsius. To figure out Q of the liquid, all you need is delta T. Subtract the initial temperature from the final temperature to get delta T for the water. Basically, there's just some, I'm going to let you guys continue reading on what to do with the instructions there. You just have to do some calculations. Sorry to make you do calculations again. There's more than I forgot because I forgot the page. All right, so they said this is one kind of experiment that has been used to determine the specific heat capacities that you have been using so far. Before you analyze a couple of these experiments on your own, I do want to make a point. When you did experiment 9.4, you probably found that your thermometer wasn't entirely accurate. When you put in a mixture of ice and water, it should have read 0.0 degrees Celsius, but it probably didn't. It probably read a little bit higher than that, although it might have read lower. So we have to be careful about the accurate readings of our thermometer, and that's even worse because we don't have a super accurate thermometer, unfortunately, like this. So it says, so they want, so continue, go ahead and continue reading this, and just make sure you do the information to finish out all the calculations to finish out that experiment. Okay, that's it for now. Thank you.